Okay, so you sent over this research paper recently. Really caught my eye, actually.
Oh, yeah. Which one was that?
It gets right into something I think what everyone listening probably cares about how to learn better.
Ah, the Davis and Chan one. Effortful tests and repeated metacognitive judgments?
That's the one
Yeah,
from 2023, Educational Psychology Review. And what I like is that it's an intervention study. They actually did stuff to see what works.
exactly. Yeah, it's not just theoretical. And
Yeah.
I think for this deep dive, our mission is pretty clear,
Well,
right?
I'm in.
We want to unpack how testing yourself, maybe even before you really learn the material properly, can actually change how well you learn it later.
Okay.
And also the role of our own judgments. You know, when you stop and think, I actually get this. How does
Yeah.
that fit in?
Right. The goal being ultimately to help you listening make your learning time more efficient, more effective.
Precisely. Make it stick better.
And the paper kicks off with this concept, the forward testing effect, FTE they call it.
Yeah, FTE.
Let's dive into that. What is that in simple terms?
Okay, so the basic idea, the core insight is that even just trying to remember something, maybe even failing at it, before you actually sit down to learn it properly,
Uh-huh.
that initial effort can actually prime your brain. It sort of prepares you to learn that information better when you finally encounter it.
Hmm. Like warming up before exercise?
Kinda, yeah. Or like, imagine trying to answer questions on a topic you know absolutely nothing about, total blank.
Okay.
Then you read an article explaining it all. You're probably going to pay way more attention to the bits that answer the questions you bombed earlier, right?
Oh, okay. I see. Because you already know what you don't know.
Exactly. That's the core of the forward testing effect.
Got it. But the researchers, they weren't just happy knowing that it works. They wanted the why, didn't they?
Right. They wanted to dig deeper. Why does this happen?
And they bring up this thing called the metacognitive account. What's the thinking there?
So the metacognitive account basically suggests that when you do that first retrieval attempt, that initial test,
Even before you've properly studied.
yeah, even then, it helps you get a much clearer sense of what you already know or think you know, and crucially, what you don't know. It highlights your knowledge gaps.
Okay. Makes sense. Self-awareness.
Exactly. And that awareness lets you be more strategic when you actually start learning the new stuff. You focus your attention better. You become like a more targeted learner.
Yeah, okay. That feels intuitive. If I try a practice question about, I don't know, some historical event and I draw a blank,
Uh-huh.
then when I read the chapter on it, I'll probably zoom in on that specific event.
Precisely. Now, flowing from that idea, the researchers predicted something about the difficulty of that initial test.
Ah, right. Effortful retrieval. That was a key phrase.
Yes. The prediction was, if that initial test is tougher, if it makes you work harder to try and pull out information,
More mental sweat.
kind of, yeah, then the benefit you get for the later learning should actually be bigger.
Why? Because it makes the gaps even clearer.
That's the logic. A harder initial struggle gives you an even sharper picture of your weaknesses, leading to, well, even more focused and effective learning afterwards.
Okay. So how did they test that specific idea? You mentioned different test types.
Right. They compared cued recall tests with multiple choice tests. These were given before participants read new sections of a science text, a STEM text specifically.
And just quickly, the difference in effort there, cued recall versus multiple choice.
Cued recall is generally harder. You get a cue, a hint, and you have to actually generate the answer from memory.
Okay. Like fill in the blank almost.
Sort of, yeah. Whereas multiple choice, well, the answer's right there on the page. You just have to recognize it. Less generation, more recognition. Think recalling a name versus picking it from a list.
Got it. So cued recall is the heavy lifting. Multiple choice is maybe lighter work. Usually.
Usually, yes. So they ran the experiment. One group got cued recall before reading. Another got multiple choice before reading. What happened?
What did they find? Did the harder test lead to better learning later?
Well, they found a trend. The forward testing effect, the learning boost, it was numerically larger for the cued recall group.
Numerically larger, so the number was bigger, but
But, and this is important, the difference wasn't statistically significant. Meaning, we can't be super sure it wasn't just random chance in this specific setup.
okay. A hint, but not conclusive proof in that comparison.
Exactly. But, and this is where it gets really interesting, this pattern, this hint of cued recall being better, it only showed up when participants didn't do something else.
Ah, what was the something else?
It was when they didn't make these things called judgments of learning, or JOLs.
JOLs. Okay, we definitely need to circle back to those. They sound important.
They are, very. But Sticking with the effort thing for a second, they also tweaked the multiple choice tests, right?
Yeah, how do they make multiple choice harder?
They use really sneaky wrong answers, what they call lures.
Ah, okay. So the incorrect options looked very similar to the correct one, made you really think.
Exactly. You couldn't just glance and pick. You had to properly discriminate. More cognitive effort involved.
And what happened when they used those harder multiple choice tests?
Then the forward testing effect actually increased. It became much more similar in size to the benefit they saw with the cued recall tests.
Okay, now that seems like stronger evidence.
It really does. It supports the idea that it's not just about the format, recall versus recognition, but about the effort you expend during that initial retrieval attempt.
So making your brain work harder up front, even if it's just recognizing tricky answers, pays off later.
Seems that way. That effort is a key ingredient for the FTE.
Okay, brilliant. Let's pivot now to those JOLs, judgments of learning. What exactly are we talking about here?
So JOLs, judgments of learning, they're basically your own internal assessment, your prediction of how well you think you've learned something.
Like after I read a chapter, I might think, yeah, I think I got that, or, not so sure about that bit.
Exactly that feeling, that self-evaluation of your own understanding or your likelihood of remembering it later, that's a JOL.
And in one experiment, they had people make these judgments repeatedly, like multiple times.
Yeah, after reading each chunk of text, participants had to rate their learning 4 times, a repeated self-assessment.
4 times per section.
No!
Okay, and what happened to the forward testing effect? The benefit of testing first in that situation?
This was the big twist, honestly quite surprising.
Yeah.
When participants made those repeated JOLs 4 times after each section, the forward testing effect vanished, completely eliminated.
Wait, what? Gone.
Gone. The group that did the initial testing beforehand, they showed no learning advantage over the control group who did no prior testing at all.
Whoa, that's really weird. I would have thought actively thinking about your learning would maybe even amplify the testing effect.
Right, that's the intuitive assumption. More self-reflection should be good.
So why did it disappear? How did researchers explain this? It wasn't that the JOL somehow hurt the memory of the tested stuff, was it?
No, their interpretation is more subtle and actually quite cool. They suggest it wasn't about the JOLs directly affecting the test group's memory negatively.
Okay.
Instead, they propose something called a JOL reactivity effect.
Reactivity, meaning the JOLs themselves changed something.
Exactly. The repeated act of making these judgments seemed to make the control group, the ones who didn't get the initial tests, think more deeply about the material as they were learning it.
So asking the control group, how well are you learning this, over and over again actually made them learn better.
Precisely. It's like those repeated prompts forced them into a deeper level of metacognitive reflection. They started evaluating the material more actively, thinking more critically about their own understanding.
So that deeper processing, triggered just by the JOL prompts, boosted their learning enough to catch up to the group that had the initial testing advantage.
That's the idea. It leveled the playing field, essentially erasing the benefit the testing group would normally have had. The takeaway is kind of amazing. Just repeatedly asking yourself, do I get this, can be a potent study technique on its own.
Wow. Just the act of self-assessment done repeatedly is powerful. Now, the paper mentions some other research, Kubik et al., from 2022. How does that fit in? Something about different types of JOLs.
Yeah, that's a good point for nuance. Kubik's study used item-by-item JOLs, so participants judged their learning after each specific fact or concept.
Okay, very granular.
Very. Whereas this Davis and Chan study used more aggregate JOLs, judging learning after a whole section of text.
A broader judgment.
Right. And Davis and Chan suggest that maybe those item-by-item JOLs used by Kubik might actually trigger little mini retrieval attempts for each item, like tiny self-tests.
So making an item-by-item judgment might itself involve a form of retrieval practice.
Potentially, yes. They call it covert retrieval. Whereas the aggregate JOLs in their study, covering a whole chunk of complex text, might be less likely to trigger that immediate, specific retrieval for every single detail.
So the way you ask yourself, how well am I learning, matters. Item by item might be different from judging a whole section.
It could explain some differences in findings across studies, yeah. This study focused on the aggregate ones, where the reactivity effect seemed more prominent in boosting the control group, like asking, do I get this whole report section? versus do I get this specific sentence?
Okay, that's a subtle but important distinction. Now, they did add a note of caution about these JOL effects, didn't they? It wasn't always a super strong effect within every single experiment.
Correct. They were careful to point out that this JOO reactivity effect, the control group catching up, was something they mainly saw when comparing results across the different experiments in their paper.
Not always hitting statistical significance within one single experiment.
Right. So it suggests the effect is likely real, but its strength might fluctuate based on, the exact learning situation, the material, maybe even the individual learners. It's not an ironclad guarantee every single time.
Got it. A consistent trend across experiments, but maybe some variability within each one. Okay, let's pull back a bit. We've got effortful retrieval being good and repeated JOLs having this surprising reactivity.
Mm-hmm.
How do we translate this into practical advice for students, educators, or just anyone trying to learn something new?
Well, I think the big takeaway for practice is definitely keep using testing and retrieval practice. It works. But maybe think about how you're testing.
Make it harder.
Yeah, lean towards methods that require more active generation, like trying to recall from memory, maybe using flashcards effectively, or explaining concepts out loud rather than just passively recognizing answers.
Even if you use multiple choice, maybe seek out questions with really tricky distractors.
Exactly. Make it demand that cognitive effort. That seems key for the forward benefit, for preparing you for future learning.
Okay. And what about the JOLs? This reactivity thing is fascinating.
It really is. It suggests that building in moments of deliberate self-reflection, consciously pausing and asking, how well do I really understand this, can be incredibly valuable, even without a formal test.
So it connects to that whole idea of self-regulated learning, being aware of your own process.
Absolutely. People like Bjork have talked about this for ages. Metacognition is crucial. This study just gives a really specific, maybe unexpected example of how powerful it can be. Just prompting that reflection repeatedly boosted learning significantly for the control group.
So for someone listening,
Yeah.
maybe they're prepping for a big meeting or trying to get up to speed on a new project,
Uh,
instead of just reading piles of documents passively.
right. They could try maybe stopping after each section or key document. First, try to recall the main points without looking. That's the effortful retrieval part.
Okay.
And then also consciously ask themselves, okay, on a scale of 1 to 5, how well do I actually get this section? Where are my fuzzy points? That's weaving in the JOL part.
So it's not just about putting in the hours, but making those hours more active, more reflective.
Exactly. Active engagement, both with the material through retrieval and with your own understanding through metacognition. Though, remember the nuance. In this study's specific setup, those repeated JOLs eliminated the relative advantage of prior testing. It doesn't mean JOLs are bad, just that they can have complex effects. They boosted the control group here.
It's like metacognition is generally good, but how you implement it interacts with other strategies in sometimes surprising ways.
Well put. It's a dynamic process.
Okay, this has been super interesting. Let's try and boil it down. What are the main headlines for you, our listener, to take away from this deep dive?
All right, 3 main things, I think. First, testing yourself before you learn related stuff can genuinely help you learn that new stuff better later. That's the forward testing effect. It's real.
Okay. Point 1, test early.
Point 2, making those initial tests harder, requiring more mental effort to retrieve the information, seems to make that future learning benefit even bigger. Effort matters.
Point 2, make the tests effortful.
And point 3, the surprising one, just repeatedly stopping to think about how well you're learning something. Those JOLs can significantly boost your learning all by itself, even without prior testing. This reactivity effect is powerful.
Point 3, repeated self-assessment boosts learning too. Okay,
Those are the core findings, yeah.
perfect. So to wrap up, here's maybe a final thought for you to chew on. Now that you know that effortful recall seems key for that forward testing boost, how might you actually change your study habits? Will you build in more self-quizzing that forces you to generate answers?
And thinking about that surprising power of just reflecting the JOL reactivity, could you be more deliberate about building in moments of self-assessment, even brief ones? Stop, do I really get this paragraph? Could I explain it? Maybe even when you're not formally studying.
Yeah, consider how these ideas fit your learning style, the kind of things you need to learn. It's about finding what works for you. Really fascinating stuff. Thanks for joining us for this deep dive.